Okay, our next lesson is all about solving complex quadratic equations, and I'm going to give you 4 examples here. Let's try to complete everything. First is 4x power of 4 minus 17x squared plus 4 is equal to 0. So basically, if you notice, the degree is x power of 4, and we haven't learned anything about solving equations that has a degree in that level. So what we are going to do is to transform this one into a quadratic equation. If we can change it, we can transform it. But if you cannot transform it, then it's not a complex quadratic equation. So let us transform. Transforming it is, we are going to use substitution method. So what are the things that we can do so that we can transform this equation into a complex quadratic equation? Remember, 4x power of 4 can also be written as 4x power of 2 to the power of 2. Okay? I hope that I made myself clear with this. So 4x power of 4 can also be written as 4x power of 2 power of 2. Why? 2 times 2 is 4. Okay? Remember your rules. A power of n power of m is equivalent to a power of n times m. Okay? So I'm basically just want you to recall on your indices rules. Okay? Next. So if that is the case, this can be 4x power of 2 to the power of 2 minus 17x to the power of 2 plus 4 is equal to 0. So since it will be like that, I can substitute x power of 2 into something. I can substitute it with any variables that I want. So I will just change this y is equal to x squared. So I'm just going to let y becomes x squared. So it will now become 4y squared minus 17y plus 4 is equal to 0. Okay? If you notice now, it becomes a quadratic equation. So it's possible that we can change this equation into a quadratic equation. After that, we will now be using factorization to get the values of y. But remember, we are not solving for y, we are solving for x. Okay? So let's factorize this one. 4y minus 1 and y minus 4 is equal to 0. I usually recommend my student to use their calculators to do this. But again, before you use your calculators, you must know how to use it. Usually my students will say mode. Okay? There. So I have these factors. So the values of y now, it's common sense. It will just become y is equal to 1 over 4. So that is the first value of y. And the second value of the y is equal to 4. This is the second value. So there are 2 values of y, but these are not the solutions. Why? Because it's just a y. I am not solving for y, I am solving for x instead. So since I am solving for x, then I will just replace this by this one. So it will become 1 over 4 is equal to x squared. That is solution number 1. Okay, solution number 2 will be 4 is equal to x squared. Remember, so that we can solve this, you have to square root both sides. Square root, remove this. So x now will be equivalent to positive or negative value of 1 over 2. And here, square root. Oh, remember, why did I wrote positive or negative? Usually, if we square root both sides, it will become positive, negative. Okay, the same thing here, it will become positive, negative. So values of x here are positive, negative 2. So there are 4 values of x. X are 1/2, negative 1/2, 2, and negative 2. Okay, so we are now going to letter B. Okay, you already know that we can use substitution in transforming an equation like this into a quadratic equation, a simple quadratic equation, because this is very complex. And you know that this is x power of 2 over 3. So it will become, this one can be transformed as 3 times the value of x to the power of 1 over 3. Okay, x to the power of 1 over 3 to the power of 2. Why? Because 1 over 3 times 2 is 2 over 3 basically. Okay, next, minus 5x to the power of 1 over 3 plus 2 is equal to 0. Thus, if I am going to let y is equal to x to the power of 1 over 3, then it will become 3y squared minus 5y plus 2 is equal to 0. This will become 3y, y. This will be 1 and 2, both negative. Okay, is equal to 0 using the factorization method. Okay, so therefore y sub 1 is equal to 2 over 3 and y sub 2 is equal to 1. Two solutions. Solution number 1, I have x to the power of 1 over 3 is equal to 2 over 3. Okay, and solution number 2 is x power of 1 over 3 is equal to 1. Okay, I am going to cube both sides. Why do I need to cube both sides? Because I just basically want to remove this. Do the same thing as the solution number 2. Cube both sides. Okay, so I have now x value, the first value of x is equal to 8 over 27. And the second value of x is equal to 1. Let's go to letter C. Letter C will be, you notice this one? This one can also be x is equivalent to x power of 1/2 times x power of 1/2. Correct? Or it can be written as x is equal to x power of 1/2 to the power of 2. X value. So, therefore, and also remember, x power of 1/2 is equivalent to square root of x. Okay? So it will become x to the power of 1/2 to the power of 2, which is equivalent to x, this one, minus 4 to the power 4 times x to the power of 1/2 minus 21 is equal to 0. Thus, if you let y is equal to x power of 1/2, then it will become y squared minus 4y minus 21 is equal to 0. Okay? Coming into that, let's get into the factorization. I have now factors are y minus 7 and y plus 3. Okay, so therefore I have two solutions. y1 is equal to 7 and y2 is equal to negative 3. Okay, my problem here is, will I consider both? If I am going to change, I have two solutions. Okay, remember I let y is equal to x power of 1/2, which is equivalent to square root of x. So square root of x is equal to 7. Okay, and the solution number 2 is square root of x is equivalent to negative 3. Okay? Are both answers, or both the 7 and the negative 3, be considered as values? No. This is an example where one solution of the quadratic equation in terms of y is not a valid solution of the original equation in the set of real numbers. So, it is an extraneous solution. This can be discarded at this stage, and you should know that this should not be included as part of the final solution. So therefore, I am not going to consider square root of x is equal to negative 3. I will only consider square root of x is equal to 7. So this one will be discarded. Okay? So I have now x is equal to 49. Why x is equal to 49? Because you square both sides, cancel this out, this will become 7 squared is 49. So the answer here is x is equal to 49. Last is letter D. Okay, so I have now 8 times the value of 4 power of x minus 33 multiplied to the value of 2 to the power of x plus 4 is equal to 0. So basically here is you need to check the structure of the equation. This time, the term 4 power of x can be written as, so again, 4 power of x can be written as 2 to the power of 2 to the power of x. Remember, 2 and x can be multiplied. So, remember also that a power of n to the power of m is also equivalent to a power of m to the power of n. So, therefore, it can also be 4 power of x can also be written as 2 to the power of x to the power of 2. Okay, so these are basic things that you should know. Okay, and we've learned this with the laws of indices. Okay, next. So I'm just going to erase this. Let's go back to the equation. Okay, this one. So again, this will become 8 times 2 to the power of 2 to the power of x minus 33 times 2 to the power of x plus 4 is equal to 0. Thus, this one can be interchanged, the 2 and the x, so it will become 8 to the times 2 to the power of x to the power of 2 minus 33 times 2 to the power of x plus 4 is equal to 0. So I can now change and let y is equal to 2 to the power of x. If y is equal to 2 to the power of x, then 8y squared minus 33y plus 4 is equal to 0. Okay, then do the factorization. It will become 8y minus 1 times y minus 4 is equal to 0. Thus, y is equivalent to 1 over 8. That's the first value of y. The second value of y is 4. But again, we are not solving for y. We are solving for x instead. So I have two solutions. 1, 2. So 2 to the power of x is equal to 1 over 8. And 2 to the power of x is equal to 4. Remember how to solve this one. Okay, this is a sample of an exponential equation. Okay, because why do I call it exponential equation? Because the missing variable x is an exponent, is an index. Okay, so you call it exponential equation. Okay, how do we solve exponential equation? Make the bases the same. After that, you can disregard the bases and equate the indices on the left and the right of the equation. Okay, so it will become 2 to the power of x. This will become 1 over 2 to the power of 3. So it will become 2 to the power of x is equal to 2 to the power of negative 3. Remember, a power of 1 over a power of n is equal to a power of negative n. Okay? Thus, x is equal to negative 3. Why? As I told you a while ago, we can discard the bases and equate the indices. Okay, next, this one will become 2 power of x is equal to 2 to the power of 2. Thus, x is equal to 2. So there are two answers. X is equal to negative 3 and x is equal to 2. Thank you very much for listening.